Hi class, we are doing the Unit 9 review. So if you'll just print it off, and I would appreciate it if you already did it. And then I'm going through each of the problems. You can just check, make sure you have them right, but that would be the best route, I think. All right, so give each degree measure in radians. So what we do with that, first of all, we are going to take our degrees, and it depends on what you're given first. You're given the degrees and you're trying to write them into radians. So how to do that is you take your 130 degrees and you multiply it by pi over 180 degrees. Okay, what happens is your degrees divide away and you're left in pi radians, which is awesome. I like to just divide out of 10 if there's a 0 that's common. And when you divide out of 10, you're left with 13. You also have a pi up top and then 18 on the bottom. So that's what you would do with number 1. Number 2, same thing, we're in degrees. So we take our negative 285 degrees and multiply by pi over 180 degrees. So you're multiplying. Now, the degrees do divide away, but we have to divide out things. So the first thing I would know to divide out is 5. So each of those are divisible by 5. So 285 divided 5 is 57. Now remember, if it's negative, it's no big deal. It just leaves you with a negative radian. So negative 57 pi over 180 divided by 5 is 36. All right, so then you're done. That's all you do. As long as you simplified and it can't divide out, nothing else can divide further. So then you're left with your simplified radians. So that's negative 57 pi radians over 36. All right, your next one, 243. Again, you multiply it by pi over 180. So your degrees divide out. Now 243, remember the little thing I taught you in class, if you add up all the digits, you know it's divisible by 3 if that number is divisible by 3. So 2 plus 4 is 6, and 6 plus 3 is 9. So we know that is divisible by 9. Since the digits add up to 9. So I'm going to divide out a 9. And 243 divided by 9 is 27. And then 9 into 180 is 20. Then you can look and see if there's anything else that's divisible both into 27 and 20. And 27 is 3, and 20 has no divisor 3, so we are done. It's 27 pi over 20 radians. Okay, so that's what you do. Just multiply by pi over 180. For numbers 4 through 6, you're given the radians and asked to convert to degrees. So what you do in that case is just replace pi with 180. All right, that's all I do. And then 9 into 180 is 20. And 17 times 20 is 340. So you end up with negative 340 degrees. Okay. Do the same with the next one. You just replace pi with 180. And then multiply through. Now, 180 is divisible by 36, so you can just divide 180 by 36, you get 5. 7 times 5 is 35. And now we're dealing with degrees, so make sure you get your degrees in there. Next one, negative 4 times 180 divided by 45. 180 is divisible by 45, so that dividing 45 into 45 is 1, 45 into 180 is 4, negative 4 times 4 is negative 16 degrees. Okay, not too bad. Next one asks you to do a few things. First, sketch the angle. So we'll start with that. Now, 290 degrees. We know that to here is 270. So that's 90, 180, 270, and then another 20. It's about right there. Remember, we just have to be close in the right quadrant generally. So that's a 290 degree angle. Okay. Now, once you've done that, it asks you to give two coterminal angles, one positive, one negative. To find our coterminal angles, we take 290 and add 360, and we take 290 and subtract 360 in degrees, and that will give us our two coterminal angles. That means we're just rotating around again and ending up right there, so it ends up coterminal, meaning same ending, or we're going the other way in the negative direction, and we're moving the other way. So I'm not sure which directions I did on that, my bad, but you're going both ways. So we're adding 360, which means, let's see, let me make sure. Adding 360 is this way. Subtracting 360 is this way. All right. So 290 plus 360 is 650, so 650 degrees. And 290 minus 360 is negative 70 degrees. So those are our two coterminal angles. Now the reference angle happens when you tie back to the x-axis. And as we know, this is our x-axis right here, so we want to tie back to that. To tie back to that, you're going to just draw a line right to it. All right? So that is your reference angle. Let me get a different color. Right here, tying back to the x-axis is your reference angle. What is that? Well, we've traveled 290 degrees, and if we traveled to the x-axis, we would be at 360. So to find the reference angle, we would take our 360 and subtract 290, and the leftover is the angle, and it's going to be 70 degrees. I always remember those reference angles are always positive. All right, next one is negative 4 pi over 5. Now we have to go in the negative direction, so we're going to move negative this way. Now, this denominator means that I'm moving to pi in 5 equal parts. So 1, 2, 3, 4, 5 to pi, but the top says I only want to go 4 of those. So 1, 2, 3, 4. Okay? And that's your angle. That's negative 4 pi over 5. Okay? So again, we break up pi into 5 parts and we traverse 4 of them. All right, so that's going to be your angle right there. Now to find the coterminal angles, we do the same thing as above, but now we're dealing with fractions. Negative 4 pi over 5, and we're going to add 2 pi, and negative 4 pi over 5, we're going to subtract 2 pi. All right, now we have to make those denominators the same so we can add them. So we need a 5, so we're going to times by 5 over 5 and get 10 pi over 5 instead, so that we can add and subtract. All right, so negative 4 pi over 5 plus 10 pi over 5 is 6 pi over 5, and negative 4 pi over 5 plus 10 pi over 5 is, negative 14 pi over 5. So it's subtracting, we get negative 14 pi over 5. All right. And then our reference angle, that means what is this angle right here? If we tie back here, what is that angle? And if we've traversed 4 pi over 5 to get to pi, we have one more pi over 5, and that gives us 5 pi over 5, which is just pi. So we're missing a pi over 5 to get to pi. And that's your reference angle. All right, we're down with 8 minutes, so we'll move on. Probably do a couple more. Next one says the terminal side of an angle in standard form passes through the point 6, negative 4. Make a sketch. So we want to go over 6 and then down 4 to get to that point right there. Whoops, I sort of missed it, so I couldn't see past my arm. Try it again. So negative 4 and positive 6 as my coordinates. That's 6, negative 4. Ties back, makes a right angle there and a theta there. Okay, so we have gone 6 over and 4 down, so negative 4. And those are our two sides. We need the third side, which is the hypotenuse. And to find the hypotenuse, we have to use Pythagorean's theorem. So we do square root of 6 squared plus negative 4 squared. Right, which is square root of 36 plus 16. 36 plus 16 is 52, so square root of 52. And that simplifies because 52 has a 4 times 13. So it's going to be 2 radical 13 for that side. Okay. Now I have all my sides. I'm going to find my sine, cosecant, cosine, secant, tangent, and cotangent. Now, up to this point, I haven't showed you, or maybe I did show you this trick. All of them are divisible by 2. So any 2 that I put in a ratio are going to give me a chance to simplify. So I'm just going to, in another color, so I know it's really 6, but I'm going to divide out 2. So I have dividing out of 2 leaves me with 3, dividing out of 2 leaves me with -2, and dividing out of 2 leaves me with radical 13. And even though I know the green is the original side measures, I'm going to go with my red when I set up my ratios because the red is the simplified form, and when I build them, they're already simplifying. I don't have to simplify when I build my ratios, which is what I like. So my sine of theta is y, remember that's y over r. So y over r is -2 over radical 13. And the cosecant is negative radical 13 over 2. So I'm going to set those up first, but then I do need to rationalize. So I'm going to multiply by radical 13 over radical 13. I get -2 radical 13 over 13 for my sine. And then my cosecant is negative radical 13 over 2. So that just helps me because I don't have to simplify each and every time I set them up. They're already simplified. And then I do have to rationalize at times, but that's pretty easy compared to doing both, simplifying and rationalizing. Cosine theta is x over r. So we have x is 3 over r radical 13. And secant, I like to do it before I rationalize because rationalizing messes things up when I'm finding the reciprocal. But I need to multiply by radical 13. And I get 3 radical 13 over 13 for my cosine. All right, tangent is, remember, y over x. So y is -2, x is 3, and the cotangent is reciprocal. So we're done with that one. All right, that's about the first half, time-wise. I'm going to stop the video, and we'll move on to number 10 in the next video. So this review will have 2 videos. So I don't want to go over 15 minutes on the first one. So anyway, watch the next one to finalize your review.